Let's talk about ratios and proportions using the multiple batches perspective. In this video, we'll talk about representations and focus on additive reasoning. First, we'll look at this word problem. My favorite trail mix recipe calls for 3 parts nuts for every 2 parts of dried fruit. I want to use all 9 cups of nuts that are in my pantry. How many cups of dried fruit do I need to make my favorite trail mix? First, let's start with a basic drawing and figure out how we can solve this problem. So my original recipe calls for 3 parts nuts and 2 parts dried fruit. So this is my first batch. And if I want to make more, I would repeat this and I would say, well, I need to add another 3 cups of nuts and another 2 cups of dried fruit. I'm making a second batch and I reference my original amounts from my original ratio. So here's my second batch, and then I come along and make a third batch. 3 cups nuts, 2 cups dried fruit, and at this point I notice that I have a total of 9 cups of nuts and a total of 6 cups of dried fruit. So in each case, I added the amount from my original ratio. Here I added 3 cups nuts, and I added another 3 cups of nuts. On the other side, it wouldn't make sense to add 3 cups of dried fruit. I start with my original ratio. By adding that original amount each time, I can make multiple batches of the same recipe. So my answer here is I need 6 cups of dried fruit. Okay, let's look at another strategy. I can make what's called a ratio table, and again, in this case, I'm going to use additive reasoning. In the future, we'll get more sophisticated and go to multiplicative reasoning, but for this video, we're sticking to really intuitive adding by repeating the original amount. So my ratio table is going to have a label, nuts, dried fruit. I record my original ratio. Notice that the recipe called for parts, and I'm making this into cups. I could have used tablespoons, I could have used quarts, I could have used any number of different things. But I'm going to go on the same procedure where I started with 3 cups nuts, so I'm going to add another 3. And I can keep adding for each batch another 3 cups of nuts. For the dried fruit, I'll add 2 cups of dried fruit. I'm stopping here because I got to 9, my desired amount, but I could keep going. I could make this 3, 6, 9, 12, 15, 18, and go on and on and on. Down here I have my even numbers. Now notice that my table has a third row because I might be interested in the total amount. So here I can just add 3 plus 2 gives me 5, and I'm going to end up 6 plus 4 gives me 10. Notice in each case I'm going to jump by a total of 5 because I added another 3 cups nuts, 2 cups dried fruit, so another 5 cups. This is going to be plus 5. To give me 15, and I could keep going here. So if the question had been, if I have 9 cups of nuts in my pantry, how many total cups of trail mix can I make, assuming I have enough dried fruit? All right, let's go to another method. Now I'm going to look at a double number line. In this case, I'm going to have 2 number lines that start at the same spot and extend, and I'm going to be really careful such that the tick marks on the top perfectly align with the tick marks on the bottom, so I wouldn't have them offset from each other. I'm going to label the top number line with one part of my ratio. It doesn't matter which part, but I'm going to go with cups of nuts. Here we have cups of fruit. We start them both at 0, and for every 3 cups of nuts, I have 2 cups of fruit. Then I can just fill in my number line here. And I can look at, I need 9 cups of nuts, and the corresponding value is 6 cups of fruit. In this, we can look at, let's switch to the highlighter actually, that this was my first batch, and my second batch, and my third batch. So I made multiple batches. I have 3 batches of trail mix, 9 cups of nut, 6 cups of fruit. All right, my last representation is going to be a graph. And this is basically where I take my double number line and swing the one of them vertical. So I'll have one axis will be nuts and one axis will be fruit. It doesn't matter which one I go with. Let's see, this is my favorite trail mix. I'm going to add a title to a graph. And in this case, because I use less fruit, I'm going to give it the shorter axis, but you could put the nuts on the vertical axis. It doesn't matter. So I have both parts of my ratio. If I don't use any fruit, I don't use any nuts. If I use 3 cups of nuts, I use 2 cups of fruit. And notice that I'm going to step over 3 and up 2. Over 3 and up 2. And I can continue that as long as I want. And I can connect these with a line. And then I can read any value here. I can look and say if I have 9 cups of nuts, that's going to correspond to 6 cups of fruit. So this was 4 different ways to represent this problem, all of them using the additive reasoning. Key in the additive reasoning is that we are making note of our original ratio and adding appropriately. So in this case, 3 to the nuts, 2 to the fruit, as opposed to trying to add equally, like 2 to both, or 3 to both, or 4 to both. That's one mistake that people make, is they say, oh, I'll just add 4 cups to the nuts, then 4 cups to the fruit, and it'll be the same ratio, but it does not work that way.